Okay, 11.7 is talking about surface area and volumes of cones. Surface area. Surface area has to do with the outer part of the shape. That's not just with cones, but with any shape. Any three-dimensional shape has a surface area. If you took let's just say a cylinder, or a pop can, and you were to cut that pop can in half. Okay, cut it in half. What you would have is the surface area. You would have a rectangle, okay, sprawled out with a semicircle on top and a semicircle actually no, sorry, not a semicircle, two circles. You'd have a circle on top and a circle on bottom. Okay, and what that covers, cut up and everything laid out, is the surface area. It's really just the area that it takes up. Surface area of a cone looks like this. If you were to take a cone, or like a little Dixie cup that you pour water into, and you cut that from the base to the top of your cup, you would come up with you'd have this. So it looks like this, and a circle. And you have to find the area of both of those to find the surface area. I'm not going to spend a ton of time on surface area. That is how surface area works. What I'm going to pay attention to a lot today is the volume of a cone. We did the volume of pyramids back in 11.6 in our last lesson. Now we're doing volumes of cones. And it's a very similar concept to the pyramids. In the last lesson, I took 3 pyramids to fill up a cylinder. A prism. In this case, a cone with the exact same base as a cylinder and the exact same height as a cylinder, same thing. It takes 3 cones to fill up 1 cylinder. So, the surface area of a cone, how we find the area of that cone, is this: pi r squared, okay, and pi rl. We add them together, where L is the slant height. It's the slant height of that shape. Okay, that's L. B, or R is the radius of our base. There's R. So that is surface area. Volume is very similar to that pyramid. It's 1/3 times the base times the height. Or base times height divided by 3, same thing. Remember, base is the area of the base. So if you want to write this, if you want to think of this instead, area of the base in a circle is pi r squared. I'm going to take that, multiply by the height, and divide it by 3. Because B is equal to pi r squared. Okay, first thing, find the surface area of the cone. Now, surface area is equal to pi r squared plus pi r l, I think. Hold on, let me triple check there. Wow, there we go. We got pi r squared plus pi r l. Okay, so what is r? R is this 3 centimeters right here. So pi times 3 squared plus pi times 3 L. L is the slant height. The slant height in this case is 5. When I solve this, 3 squared is 9, so it's going to be 9 pi plus 15 pi. 9 pi plus 15 pi. So S is equal to 24 pi. .24 times pi is 75.4. And since this is area, it's squared. Inches squared. Or sorry, centimeters squared, not inches squared. Centimeters squared. Alright. Next problem is a little different, a little funky. They say that a right cone has a diameter of 8 inches and a height of 3 inches. So, remember our formula. We need to have L. We need the slant height to solve the surface area. And in problem number 2, they don't give us the slant height. Instead, they say a right cone. Okay, what that means is in our cone, that's horizontal. We'll move this over. A right cone is kind of that perfect cone where if you drew the height straight down to the radius and go straight to the center. Okay, and then this would be the radius and create a nice right angle. Okay, that's what a right cone is. It has a diameter of 1.8, which means the radius is 0.9. Right, half the diameter is the radius. The height is 3 inches. We need to find the slant height. And we can find that using the Pythagorean theorem, because what we have here is a right triangle. Okay, so to solve for that slant height, to solve for L, we're going to take 3 squared plus 0.9 squared and set that equal to L squared. So 9 plus 0.81 is equal to L squared. 9.81 is equal to L squared. You got to take the square root of both sides. So L is going to be equal to, let me type that into my calculator, 3.13. Yeah, that's our slant height. That's not their surface area. We're trying to find the surface area. So we have to plug this in. S is equal to pi times R is 0.9 squared, plus pi times 0.9 times 3.13. Okay, so S is equal to 0.81 pi plus 2.82 pi. S is equal to 3.63 pi, and when we multiply that by pi, we get 11.4. This is inches squared. Alright, that's surface area. Now let's get to volume. Remember, the volume of the cone, is equal to base times height divided by 3. Or pi r squared times height divided by 3. I like this second one better. That's what I'm going to work with. R is our radius. That's 3 centimeters. So volume is equal to pi times 3 squared times our height. Our height is 4 divided by 3. Volume is equal to 9 pi times 4 over 3, which is equal to 36 pi over 3. All I did was multiply 9 and 4. 36 divided by 3 is 12 pi. Multiply that. 12 pi is equal to 37.7. 37.7, this is centimeters, and we're talking volume, cubed. A right cone has a radius of 5 feet and a slant of 13 feet. So if you were to think of this cone, again, it's a right cone. So the height is perfect right over the center of our cone. It has a radius of 5 and a slant height of 13. We have to think of what's our height. We have to find our height. Have to know it. Well, we can use the Pythagorean theorem, right? H squared plus 5 squared is going to be equal to 13 squared. You solve this. H squared plus 25 is equal to 169. All I did was square our numbers. Subtract 25 from both sides, you get 144. Square root of 144 is our height. It's 12. So this is important. It's important because we need that for our formula to find the volume. Volume is equal to pi times r, which is 5 squared, times our height. We just found that. That's 12. I divided all of that by 3. V is equal to 25 pi times 12. That's all over 3. I'm just going to plug it into the calculator. 25 pi times 12 divided by 3 is 314.2. This is feet cubed. Number 5. 5 through 7, we have to find the indicated measures. A right cone has a surface area of 440 square inches and a radius of 7 inches. Find the slant height. So remember, surface area is equal to pi r squared plus pi r L, where L is the slant height. They give us the surface area, it's 440 square inches. That's equal to pi r, they give us r, it's 7, plus pi times 7, we don't know what L is. That's what we're trying to find. Okay, so 440 is equal to 49 pi plus, I'm going to rewrite this as 7 times pi times L. I'm going to simplify 49 pi. Actually, I'm not going to simplify, I'm just going to write that out as a number. That's 153.9. So 440 is equal to 153.9 plus 7 times pi is about 22. I'm going to say 22 L. Now it's just a simple equation. We can just solve for L. Subtract 153.9 from both sides. 440 minus 153.9 is equal to 286. 0.1. That's equal to 22L. Divide both sides by 22, and we get 13 inches. Okay, so again, it's just plugging it in and trying to solve for the missing length or variable. Number 6, red cone has a volume, so now we're talking volume. Remember, volume is equal to pi r squared times height, all over 3. They give us the volume. It's 528, so 528 is equal to pi r. We don't have r, we have diameter of 12 meters, which means the radius is 6. We don't know what's height. It's all divided by 3. A couple different ways to solve this. First thing, 528 is equal to 36 pi times h divided by 3. You can do one of two things. You could simplify 36 over 3, make that 12, or you can multiply by 3 on both sides. I'm just going to simplify the fraction. So 528 is going to be equal to 12 pi times h. Because 36 divided by 3 is 12. Now I'm going to divide both sides by 12 pi. 528 divided by 12 pi, final answer. I'm going to include parentheses. Should get 14. If you didn't get 14, you didn't include parentheses. 14 meters. Last two problems. We have similar objects, similar shapes. Okay, now with 3D shapes, we have to cube either the measure. We have to cube the measure, and don't cube the volume, cube the measure. Well, A and B are similar. The radius of A is 4 centimeters. The radius of cone B is 10 centimeters. The volume of cone A is 134 centimeters. Find the volume of cone B. We're going to do this setting up a proportion. We're going to say 4 over 10 is equal to 134 over V for volume of cone B. So we took the radius, set it up as a proportion, 4 over 10. Took the volumes, set it as a proportion, 134 over V. And now, we have to cube our measures. We have to cube our measures, not our volume, but our measures. So we're going to cube these. So this rewritten as a fraction, 4 cubed is 64. 10 cubed is 1,000. That's still equal to 134 over V. Now we solve this by cross multiplying. So 64V is equal to 134 times 1,000 is 134,000. And now we just divide both sides by 64. Should be 2,093.8 roughly. And it's centimeters cubed. So similar shapes, you have to cube our measure. Last problem. It says find the volume of the composite solid. These composite solids, what we do is we break it up into two shapes. Let's start with just the cylinder. And let's start with just this. Remember, volume of this is just pi r squared times height. It's just base times height. The radius of the cylinder is right here. It's 2. So V is equal to pi times 4, because 2 squared is 4, times our height, which is 5, which is 20. So V is equal to 20 pi. Okay, 20 pi is 62.8. That's the blue shape. Next, we're going to focus on the cone. And the volume of that cone is pi r squared times height, but we divide it by 3. So the volume of this is, the radius is still 2, so pi times 4 times our height, which is right here, 4, all over 3. So V is equal to 16 pi over 3. Back to your calculator, 16 pi divided by 3 is 16.8. To find the volume of the whole thing, we just add these together. We add the two volumes. That's 62.8. Overall volume, 79.6 inches cubed. If you have any questions.